Hello everyone, Dr. Chen here. So in this chapter, we're going to learn electric forces and electric field. So let's start with electric charges. So the first question we have is, why do we have electricity? Like in this experiment, why do the hairs of this girl spike up? To answer the question, why do we have electricity, we need to understand what is a world made of. So you probably heard about atoms, but atoms is not the fundamental particle of the world. Atoms has nucleus and electrons. Now, electron is one of the fundamental particles we know by now. But nucleus is not. And we know nucleus is made of protons and neutrons. See, even protons and neutrons are not fundamental particles. Protons and neutrons are made of fundamental particles called quarks and gluons. But we don't need to go there. Let's stay with protons and neutrons. So we have three particles to investigate. We have proton, neutron, and electron. Proton and electron, they have defined mass, charge, and size. What does that mean? It means every proton has exactly the same mass, charge, and size. We can't really distinguish individual protons and electrons. Now, mass we're familiar with. We'll give you the number of protons and electrons later. And then charge. Charge is a quantity that is just as fundamental as mass. So a fundamental particle has mass, and then we would ask what would be the charge and what would be the size. The size of a proton we'll see in the next extremely great video, which zooms in from our microscopic lens all the way to the atomic lens to see what would be the fundamental constitute of the world. So this is our scale. This is 1 centimeter. So now this is the smallest fundamental constituent of the world we know of. So we have quark. quarks. To our understanding, quarks doesn't have any size. And actually, inside a proton, we should be able to observe something called a gluon as well, which is not demonstrated here. And the size of a proton, we know, proton is roughly 1 Fermi. You ask, what is 1 Fermi? 1 Fermi is 10 to the negative 50 meter. If you heard about the word nanometer, which is 10 to the negative 9, so 1 Fermi is 1 out of 1 million of nanometer. So it's even 1 million times smaller than 1 nanometer. So that's the size we're talking about. Why we have electricity. Proton and electron are responsible for all the electricity we observed. Proton carries a charge, we call it a positive charge, and the electron carries negative charge. Protons have charge positive E, electrons have a charge negative E. This E is the fundamental charge. The number of E is 1.6 times 10 to the negative 19 coulomb. So you can imagine if you have an object, that object can have maybe 10 protons, 5 electrons. So you can add the charge of the electrons and the proton together. You can only have integer numbers of protons and electrons inside object, right? So this is why if you have object charged, the charge of the object can only be integer multiple of those fundamental charge E as well. E, that quantity E is 1.6 times 10 to the negative 19 coulomb. The proton carries positive 1.6 times 10 to the negative 19 coulomb of charge. The electron carries negative 1.6 10 to the negative 19 coulombs of charge. Neutron doesn't carry any charge. What about mass? Look at this table. Proton mass is 1.67 10 to the negative 27 kilogram. Electron mass is 9.11 10 to the negative 31 kilogram. If you compare the mass of electron and the mass of proton, you do the math, you'll find out the proton mass is roughly 2,000 times compared to electron mass. So because proton has more mass, you can go back to what we learned in physics 1, Newton's second law, F equals ma, right? So if you apply the same amount of force to different object with different mass, which object is easier to move? Then we have A equals F over m, right? If m is small, then A would be large. So with the same force, electron would have much higher acceleration compared to proton. So electron is easier to move compared to protons. What are the other properties about charges? And we know different charge attract each other. Positive charge and negative charge attract each other. Positive charge repel each other. Negative charge repel each other. Summarized as unlike charge attract and like charge repel. Now, this positive and negative charge are named by Benjamin Franklin. There's another important property about electric charge. Electric charge cannot be created or destroyed. So in the sense that the total electric charge in the universe is a constant. Charge can only move to one object to another object. Now, we can have electron move from one object to another object. Then the object has more electrons, the proton will carry net which means total negative charge. So the object loses electron or carry total positive charge. That's how we charge an item. And human civilization have observed and understand electromagnetic phenomena as early as almost 3,000 years ago. Found amber can attract small piece of objects, and we invented compass to direct direction for us because Earth has a magnetic field and is pointing from not. Now, fast forward the time to 1600. Around that time, people started to notice electrification that is not limited to amber. And Benjamin Franklin, 1752, he used a famous Kite experiment to prove lightning is electricity. And as Benjamin Franklin defined, the charge carried by proton is positive charge, and the charge carried by electron is negative charge. Coulomb used the experiment to find out what would be the electric force between charges. Hence, Ørsted found out electric current can produce magnetic field. Michael Faraday found out a changing magnetic field can give us electric current. And James Maxwell summarized everything about electromagnetism in 4 equations, which give us complete theory about the electromagnetism. So we can solve any problem with those 4 equations. And Hertz derived from Maxwell's equation found out the electromagnetic waves, which plays essential role in modern society because we have radio, TV, cell phone, is all electromagnetic wave. Oh, by the way, the visible light is also electromagnetic wave. So think about this question. If we rub a balloon with our hair, then we have some movement of charge. After movement, the total charge inside the balloon and the hair, what's going to happen?